Jai Hind students, welcome to my YouTube channel. Students, when we believe what we think, then we shall also believe what we say. So with such optimism on the bedrock of reality, success is bound to come. Therefore students, keep telling yourself that everything is possible for you. So do believe in your abilities and do tell yourself always that I will definitely succeed, for I believe all what I say. So with such optimism, let's start this session, and in this lecture we are going to discuss a very important topic, and that is projectile and projectile motion and various concepts associated with projectile motion, right? So during this session we'll be discussing the projectile, what all are the motions possessed by a projectile, some terms, definitions, and in between I will also show a short clipping which is very, very interesting, and I'm very sure you will like that, right? So let's start with the intro then. Students, let me start with few examples, like when a bullet is shot from a gun, or a shell fired from a cannon, or the throwing of a javelin by a javelin thrower, or a football is kicked by a player, or a stone is dropped or released from the window of a moving bus. These all are the examples of projectile. So what is the common in all these things? Can you state what is the common in all these examples? The common point in all these examples is that, students, the body is projected in air or space, and its motion is only and only under the influence of gravity alone. So, any body which is thrown in air or space and is under the influence of gravity alone, that may be termed as a projectile, right? So students, let's deal it in detail. So these are the examples which we have discussed. Suppose this is a building and this is the ground, and from the top of a building a body is flicked, or it is given horizontal velocity. It is imparted horizontal velocity. Then it will tend to follow a path like this. This is the first example. Second, suppose this is the ground and a football is there and a player kicks this football along that direction, making an angle theta with the horizontal. So it tends to follow a path like this. Third, suppose this is a cannon. Let us consider this to be a cannon, and a shell is fired from this cannon. This is a shell. It is fired at an angle theta from this cannon. So obviously it will tend to follow a path like this, isn't it? Another example, students, fourth one. Suppose we consider the case of a moving bus or a moving train. This is a bus or a train which is moving along this direction with velocity, and these are the windows, and a person drops a stone or a ball from the window of a moving bus. Now in this case, this ball or this stone will follow a path like this, and this is supposed to be ground. Right, students? Okay. Fifth, let's consider another example, right? Let us consider this case. Suppose this is a building and this is an imaginary line parallel to the horizontal, and a body is projected making an angle theta with this imaginary line which is parallel to the horizontal. Then the body will follow a path like this. This is a projectile, right? Sixth, as we have discussed, a bullet fired from a gun, it will be like this. This is suppose a bullet. As soon as it gets released from the barrel of the gun, what happens is it will tend to follow a path like this. So this is again the example of a projectile motion. Then the case of a throwing of a javelin by an athlete, that is also an example of projectile. So students, in all these examples, the body is under the influence of gravity alone. Whenever the body is given some initial velocity, whenever it is thrown in air or in space, its motion is only and only under the influence of gravity alone. So such a body is known as a projectile. Right? Again I repeat, students. In this case, when the body is flicked from the top of a building or given some horizontal projection, it tends to follow a path like this. So during its motion, it is only and only under the influence of gravity. No fuel or engine is there in the body. It is moving due to the gravity alone and due to its horizontal velocity, due to its angle of projection. Understood, students? So, whether a body is given some horizontal velocity from the top of a building or a body is kicked from a point on the ground making an angle theta with the horizontal, right? Or a body is dropped from the window of a moving bus or a train. These all are the examples of bodies which can be classified as projectile. Clear, students? So, what is the definition of projectile then? Any body which is thrown in air or space and which possesses motion, which is only and only under the influence of gravity alone. That may be termed as a projectile, right? And remember, students, in all these cases, the body is covering some horizontal distance as well as it is covering some vertical distance. So, projectile motion is an example of two-dimensional motion. It is a two-dimensional motion. Look, from this time to this time, during which the projectile remains in air, the body is following this path. So, it will cover this horizontal distance and this vertical distance, isn't it? Here also, the vertical distance is covered as 0, but horizontal distance is covered as this one. So, here also, it is covering vertical distance, this one, and this is the horizontal distance. In this case, suppose initially at t equals 0, the body is projected in the upward direction, and at t equals to capital T, the body strikes the ground. So, during capital T time, the body remains in air or space. So, during this time, students, the body has covered this vertical distance and the body has covered this horizontal distance. So, in each of these cases, the body possesses two types of motion. One is the horizontal motion, the other one is the vertical motion. So, there are two types of motion possessed by a projectile, horizontal and vertical, right? We will discuss these things in detail. First, I will rather request you to watch this short clipping, right? And thereafter we will continue with our session.
Any object projected into space or air such that it moves under the effect of gravity alone is called a projectile. The path followed by the projectile is called its trajectory. The motion of the projectile is considered as the combination of two independent motions along x direction and along y direction. Galileo in 1632 was the first to state that horizontal and vertical components of the projectile motion are totally independent of each other. The two independent motions possessed by the projectile are, first, the motion along horizontal path with uniform velocity, and second, motion along vertical path which is under the influence of gravity. The body during its motion is always under the influence of force of gravity, and hence the vertical path is under uniform acceleration which is equal to small g, which is the acceleration due to gravity. along x direction, if the air resistance is neglected, then the body is under the influence of balanced forces, and hence the acceleration along x direction is 0, and therefore the velocity component along the horizontal direction always remains constant throughout the motion of the projectile. Therefore, the horizontal velocity, it remains constant throughout the motion. While on the other hand, if we consider the motion of the projectile along y direction, then since it is uniformly accelerated motion, that is, it is under the influence of force of gravity, thus it is under the influence of unbalanced force. And due to this acceleration, what happens is the vertical component of velocity of the projectile, it will keep on decreasing when the projectile gains in height. At the maximum height, the vertical component of velocity will become 0. And when it comes down, then the vertical component of velocity again starts increasing. And at the instant when it strikes the ground, the vertical component of velocity is maximum. This is a small depiction of the projectile motion. Let's consider a shell to be fired from a cannon at an angle theta with the horizontal. As the shell is fired, it possesses two components of velocity. The horizontal component of velocity, which is represented by the red arrow, it will remain constant throughout the motion of the projectile, while the vertical component of velocity, which is represented by the green arrow, it will keep on changing as it is under the influence of acceleration due to gravity.
So students, a projectile, it possesses two types of motion, and those two types of motions are, one is the horizontal and the other one is the vertical. First type of motion is the horizontal motion. As a result of which the projectile tends to cover some distance along the horizontal direction, right? And horizontal motion is with constant velocity. We'll discuss it. And second is vertical motion. And vertical motion is under the influence of gravity. Under the influence of gravity. So these are the two types of motion possessed by a projectile. The horizontal motion, which is uniform motion. That is, the body covers or it possesses horizontal motion with uniform speed, uniform velocity. Acceleration along the horizontal direction is 0. And it also possesses vertical motion. Obviously, it will be under the influence of force of gravity, which will act in the vertical direction. So, in the vertical direction, it will be under the influence of acceleration due to gravity. As a result of which, the velocity, that is the vertical component of velocity of the projectile, will either increase or decrease at a constant rate. So, vertical motion is uniformly accelerated motion. Horizontal motion is uniform motion, right? Let me elaborate it. Now students, remember, in the case of horizontal motion, what we have considered is, we have considered the air resistance to be negligible, right? So no horizontal force is acting on the body. In the absence of any force acting on the body along the horizontal direction, that is, if no force acts on the projectile along the horizontal direction, it implies that acceleration along the horizontal direction is 0. If no net force acts on the body along the horizontal direction, then the acceleration along the horizontal direction, that is the x direction, is 0. Which implies that if acceleration is 0, therefore velocity of the projectile along the x direction will remain constant. And when velocity remains constant, then it is the case of uniform motion. So again I repeat students. Here during the projectile motion, we will assume that the air resistance is negligible. For very light bodies, air resistance might have a role to play. But for heavier bodies, then air resistance is almost negligible, right? So here all the the mathematical derivations will be considered, assuming that the air resistance or frictional force due to the air is to be avoided or neglected. So students, in the absence of any force acting on the projectile in the horizontal direction, the velocity component of the projectile along the horizontal direction will always remain constant. So the projectile causes horizontal motion, which is actually uniform motion, which the body covers with uniform velocity, right? Vertical motion. Now vertical, as the body goes upward or it comes down towards the earth, it is always during its motion at any instant, it is always under the influence of force of gravity. The earth tends to attract the body always towards its center. So along the vertical direction, due to this force of gravity, the body will have acceleration. And that acceleration is known as acceleration due to gravity. So whenever a body causes acceleration, then what happens? Its velocity changes, right? So vertical motion, projectile causes acceleration due to gravity, as a result of which the vertical component of velocity of the projectile either increases or decreases at a constant rate. And what is that constant rate? It is 9.8 meter per second square, right? It is but obvious that if I throw a projectile upward, then what happens? Its vertical component of velocity will keep on decreasing at a constant rate. At the highest point it will become 0, and again when it comes back towards the earth, its vertical component of velocity will keep on increasing again at a constant rate of small g, that is 9.8 meter per second square. Clear, students? So vertical motion, the acceleration is either plus g or minus g, depending whether the body is coming downward or going upwards, right? So ay is plus g or minus g. Why there is the presence of ay? Because it experiences a force of gravity. It experiences a force of gravity along the vertical direction. So that is the reason why in the vertical direction the projectile will have acceleration, which is equal to the acceleration due to gravity. So vertical motion is uniformly accelerated motion, while on the other hand, horizontal motion, which it covers with constant velocity, is uniform motion. And students, always remember, these two motions of the body are totally independent of each other. They are totally independent of each other. And these two motions of a projectile enables the body to follow a certain path, which is known as its trajectory. It actually follows a parabolic path. That also will mathematically prove it, right? Okay, so again I repeat, this is a very, very important point. A projectile, as we are aware, it's a body which can be thrown in space or air, and its motion should be only under the influence of gravity. That can be termed as a projectile. A projectile basically possesses two types of motion, the horizontal and the vertical. Horizontal motion is with constant velocity. That is, it is the case of uniform motion. Why it is the case of uniform motion? Because there is no force acting along the horizontal direction. So acceleration along the horizontal direction is 0. So velocity along the horizontal direction remains constant. And the other motion caused by the projectile is the vertical motion. Now look, any body at any point will always get attracted in the vertically downward direction towards the center of the earth. That is force of gravity. Due to this force of gravity, the body is always having acceleration, which is the acceleration due to gravity. So as a result, in the vertical motion, the velocity of the body keeps changing at a constant rate. It either increases or decreases. If it goes upward, then the vertical component of velocity decreases at a constant rate. If it comes downward, then the vertical component of velocity increases at a constant rate. And that constant rate is small g, which is acceleration due to gravity, right? And these two motions it's very important, are totally independent of each other. And Galileo was the first person to have verified the fact that the motion, these two motions, horizontal and vertical motion caused by projectile, are totally independent of each other. Right? So students, there are certain assumptions when we proceed with certain mathematical articles and derivations. There are certain assumptions which we'll consider while dealing with this topic. So I'll write down these assumptions. First assumption, student. Air resistance or the frictional force due to air is neglected. This is the first assumption. Second, effect due to rotation of Earth is neglected. Then third, effect due to curvature of Earth is neglected. And lastly, throughout the motion of the projectile, the value of small g is assumed to be constant, right? Value of small g is assumed to be constant at any point during the motion of the projectile. So students, these are the four assumptions which we'll be considering while deriving and understanding the concepts of projectile, right? So let's proceed further. Now, the two motions which we have discussed right now, horizontal and vertical motion, we'll discuss it with the help of a diagram. We'll consider two cases. One, we'll consider the horizontal projection, and the other we can consider the case of angular projection. So in these two cases, we'll try to understand the types of the motion caused by a projectile, right? So case 1, suppose. Let's consider the case of horizontal projection. Okay. This is a building, this is the ground, and from the top of this building, a body is imparted some horizontal velocity, say u, right? Later on in the subsequent lectures, we'll prove that it will tend to follow a parabolic path like this. So anyway, this is given horizontal velocity. Now look, as I've told you, horizontal motion, it is in uniform motion and it covers, the body covers the horizontal distance with constant speed, constant velocity. So at any instant during the motion of the body, this horizontal component of velocity will remain same. So the length of these arrows indicating the horizontal component of the velocity of the projectile should be same. At the instant when it strikes the ground, here also the horizontal component of velocity will remain same. So I think this should be crystal clear. No net force acts on the projectile along the horizontal direction. That is, along the horizontal direction, the projectile is under the influence of balanced forces. In the absence of any net force, acceleration is zero. Acceleration is zero means velocity along the horizontal direction is constant. So, the length of the arrows indicating the horizontal velocity must be same, right? Now, about vertical motion. It is under the influence of gravity. The body is coming towards the earth, right? The vertical component of velocity must increase at a constant rate, isn't it? Initially, the vertical component is zero. Only the body is having horizontal velocity. As it comes down, its vertical component of velocity will keep on increasing like this. And at the instant when it strikes the ground, it will be maximum. So this velocity, it is increasing in this case at a constant rate. Because in the vertical direction, the projectile is under the influence of acceleration due to gravity, right? Students, we are aware whenever a body moves along a curved path, then at an instant, the direction of motion is given by drawing a tangent at that particular point, isn't it? So, at any instant, the resultant would be given by drawing a tangent at this particular point. So, this is actually the resultant velocity at a point, right? And this is the resultant of the vertical component of the velocity and the horizontal component of velocity at that instant. I mean, it can be easily calculated by making use of parallelogram law of vector addition. These two can be considered to be the adjacent sides of a parallelogram, isn't it? And they are inclined at a right angle. So, their vector resultant both in magnitude and direction would be given by the diagonal of the parallelogram passing through the same point. So, obviously, if Vx is u, Vy, it is vertical component at this instant is Vy, then V resultant at any instant, it will be given by square root of Vx square plus Vy square. As I have stated earlier, Vx, which is the component of the velocity of the projectile along x direction, that will remain constant throughout. It will remain u only. It will be constant throughout. While on the other hand, students, Vy, it is the vertical component of the velocity of the projectile, right? This component at different instants would be different because it is under the influence of gravity. So at the instant when the body strikes the ground, the vertical component of the velocity is maximum. So the resultant velocity with which it strikes the ground would also be maximum. Here, the net velocity would be given by this one. So you can complete the parallelogram like this. So actually, resultant would be the vector resultant of Vx and Vy. Clear, students? Just simply apply the parallelogram law of vector addition, right? Let's discuss some terms and definitions in the case of horizontal projection, right? Suppose the body is projected horizontally from the top of a building at t equals to 0 and the projectile strikes the ground at instant t equals to capital T. Then students, this capital T is known as the time of flight. So time of flight is the time during which the projectile remains in air or space. And during the time which the projectile remains in air and space, it will follow a path. It will follow a definite path. The path followed by a projectile is known as its trajectory. And students will prove that in the subsequent lectures. We are going to prove that the nature of trajectory of a projectile is always parabolic. That is, a projectile always tends to follow a parabolic path. This will be mathematically verifying this particular fact, right? With the help of derivation of certain formulas, certain standard equations of parabola. Anyway, now comes range. Range is this distance. It is the distance which is travelled or traversed by the projectile along the ground or along the horizontal in the time during which the projectile remains in air or space. Now look, during time capital T, the projectile remains in air or space and it is following this path. And during this path, it has covered this vertical distance and this horizontal distance. So this horizontal distance covered by the projectile in the time during which it remains in air or space, that is known as the range of the projectile. Clear, students? So this was all regarding horizontal projection. Now let's concentrate on the second part, and that is angular projection. We will discuss angular projection. So whether it is the case of horizontal projection or it is the case of angular projection, the concept remains the same. That is, in this case also, the body, its motion, once it is thrown, it will be only and only under the influence of gravity alone, right? And it will possess two types of motion, horizontal motion and vertical motion. So let's see. It is the second case and it is the case of angular projection. That is, in this case, we will assume the body to be projected with velocity u making an angle theta with the horizontal. Suppose horizontal is represented by the x-axis, and let us consider this to be y-axis. Now, as I've stated, students, this projectile will tend to follow a particular path. The nature of the path followed by a projectile will be known as its trajectory. So, in the later section, we will prove that it will follow a parabolic path like this. It will follow a parabolic path. Now, what we do is, this u can be resolved into two perpendicular components, isn't it? We can resolve it into two rectangular components. One along the x direction, horizontal. This is the horizontal component of velocity. It will be u cos theta. And the vertical component of velocity, it will be obviously u sin theta. So students, u cos theta, u sin theta. These are the two perpendicular components of velocity of the projectile along the x and the y direction respectively. Now remember students, projectile, it possesses two types of motion. Horizontal motion. Let's first concentrate on the horizontal motion. As we are aware, in the horizontal direction, the projectile is under the influence of balanced forces. So net force acting on the projectile is zero. Therefore, acceleration is zero. And therefore, the horizontal component of velocity of a projectile always remains constant, right? Throughout the path, at any point during its motion, this horizontal component, it should remain same. So, at this point, the horizontal component of velocity would be u cos theta. At the highest point, here again, the horizontal component of velocity would be u cos theta. At some other point, again, the component of velocity along the horizontal direction will remain same. And at the point when it strikes the ground, again, the horizontal component of velocity would be same. So what I have tried to do is, I have tried to represent the horizontal component of velocity by arrows of equal lengths. So I have tried to draw these arrows of equal lengths. These are the arrows all of equal lengths, right? So no doubt regarding this. Since acceleration along the horizontal direction is zero, therefore ux is equal to u cos theta is equal to constant. So no doubt regarding this. The horizontal motion is covered, or a projectile possesses horizontal motion which it covers in uniform motion, right? So this component of velocity at any instant will remain constant. Now second type of motion, students. The second type of motion caused by the projectile is the vertical motion. So vertical, the body at any instant during its motion will get attracted towards the earth due to the force of gravity. So it will experience an acceleration. So during its motion at any point, the body will have acceleration due to gravity. It will be uniformly accelerated motion. So when it is going upwards, then it will be the case of retardation. The velocity, that is the vertical component of velocity of the projectile, will decrease at a constant rate of small g, that is 9.8 meter per second square. So what happens is, as it goes upwards, its vertical component of velocity will keep decreasing. It will decrease. And at the highest point, it will become zero. At the highest point, vertical component of velocity is zero. Remember students, this is a very, very important concept. The net velocity of the projectile at the highest point during the angular projection is not zero. It is only the vertical component of the velocity at the highest point during angular projection, which is zero. At the highest point, the body possesses only the horizontal velocity, which is u cos theta. Now, consider this case. Now, consider this half. It will become similar to that in case 1, which was the case of horizontal projection. Now, what happens is, after this, the body is coming downward. So, here, the vertical component of velocity is 0. Now, as the body comes downward, it is getting attracted, isn't it? So, it will be the case of acceleration, where a would be plus g. So, the vertical component of velocity will now start increasing at a constant rate of small g. So, now it will keep on increasing. And at the instant, when it strikes the ground, it will be maximum. So, this is the final vertical component of velocity. So, look, the arrows which represents the vertical component of velocity, it is of varying length, indicating that the vertical component of velocity is decreasing or increasing at a constant rate, and that rate is 9.8 meter per second square. Clear, students? And as we have discussed in case 1, the net velocity at any instant whenever a body moves along the curved path is given by drawing a tangent at that particular point. So these are the two components. What will be the resultant velocity at this point? It will be given by drawing a tangent over here. And this will be the resultant, which will be the resultant of the vertical component and the horizontal component of velocity. Students, these are the two adjacent sides of a parallelogram, and the resultant is given by the diagonal of the parallelogram passing through the same point. So this will give its resultant velocity. Clear? At the instant when it strikes the ground, the directional motion of the projectile would be like this. This is V resultant. And it will obviously be given by square root of Vx square plus Vy square. Because Vx and Vy both are perpendicular to each other. And whenever the two vectors are at right angle to each other, the magnitude of the resultant is given by square root of a square plus b square. So nothing new in it. So whenever a body follows a curved path or a parabolic path, the resultant direction of motion at a point is given by drawing a tangent at that particular point. And that is actually the diagonal of the parallelogram whose two adjacent sides are the horizontal component and the vertical component of velocity of the projectile at that point. Clear, students? I hope you have understood the concept, right? And remember always, here at the highest point, the vertical component of velocity is 0. The net velocity is equal to the horizontal component of velocity, which is u cos theta. If at the highest point the net velocity was 0, then the body would have simply followed the straight path, isn't it? But it is following this path due to this horizontal component of velocity. Clear, students? So now let's discuss those terms in this case as well. Trajectory, as we have discussed, the path followed by the projectile, this path which the projectile follows, is known as its trajectory. And in the case of projectile, the nature of trajectory is always parabolic, right? Time of flight. Suppose at t equals to 0, the projectile is fired. A shell is fired from the cannon, or a football is kicked by a player along this direction, right? And at suppose t equals to capital T, the body strikes the ground. So this time capital T is known as time of flight. So how will you define this time of flight? It is the time during which the projectile remains in air or space. Or it may also be defined as the time that has elapsed between the instance of projection of the projectile and the instant at which it strikes the ground. So that's time of flight. Range. Now, during the time the projectile remains in air or space, it has covered this horizontal distance. So the horizontal distance covered by the projectile in the time during which it remains in air or space, that is known as its range. So this is range. It can be represented by capital R. This would be the range. So I hope you have understood the terms and definitions related to both horizontal projection as well as angular projection. Right, students? So what we'll do is, in the subsequent chapters, in the subsequent lectures, we will discuss each and every case in detail. There are various cases, right? In each of the cases, we will try to derive the mathematical expression for the equation of trajectory, the time of flight, the maximum height attained, then the range, horizontal range, at what angle of projection the range will be maximum, what will be the net velocity with which the projectile strikes the ground. So these all topics will be discussed in the coming lectures, right? So for this lecture, that's it, students. So we'll continue with the next session then. Do join me in my next lecture. Thank you.